In the last video, we looked at a very specific case and how we can use angles and side lengths of a triangle to solve for other angles and side lengths, even when it's not a right-angled triangle. And we said that we could do that by making some right-angled triangles, by drawing a line down the middle, which creates a right angle, and then using our trig ratios, specifically the sine ratio, to solve for some unknowns. What I want to do now is look at this general triangle to create a general formula. So let's just remind ourselves the way that we label triangles is we use lowercase a, b, and c to label each side length, and then each angle is the uppercase of the side length that is opposite it. So the angle here, that's opposite the side length lowercase b, so the angle is labelled with an uppercase b, and same for a and c. So in the last video we saw how by drawing this line here, which creates these two right-angled triangles, I can label this h, and then we saw how this left-hand side triangle, right-angled triangle, we can use sine to say that sine of the angle b equals the opposite side, which is h, over a. And we rearranged to get h equals a times sine b. And then we can do the same thing for the right-hand right-angled triangle, where we would get that sine of a equals, again, the opposite h over the hypotenuse, which is b, and then we rearrange by multiplying both sides by b to get h equals b times sine a. And now, if this equals h and this equals h, then they must equal each other. So we get that a times sine b equals b times sine a. A times sine b equals b times sine a. That is the important result, general result, that will be true for every triangle. We're going to just rewrite that slightly differently, where instead of writing it as with a's and b's on the same side of the equation, we're going to change it so that we're writing it as an equation between ratios. So let's see what we're going to do. We're going to first divide both sides of this equation by sine a. So we're going to get that a times sine b divided by sine a. So I've taken this sine a, I've moved it over to this side by dividing both sides by sine a, so that equals b. And now I'm going to divide both sides of this equation by sine b. So I get that a divided by sine a equals b divided by sine b, because I've taken this and moved it over to the other side of the equation by dividing both sides by sine b. Now this result is actually much more useful, because what's this telling me? It's telling me that the ratio between a side a, this side, and the sine of its corresponding angle is equal to the ratio of any other side, let's say side b, and the sine of its corresponding angle. And if you think about that, what that means, it actually makes logical sense, because whatever angle in a triangle is the largest, let's say in this triangle it's this one, the largest angle is always going to be opposite the largest side length, and the smallest angle is always going to be opposite the smallest side length, etc. So this result makes sense. The ratio of a side length to the sine of its angle, its opposite angle, is equal to the ratio of any other side length over the sine of its corresponding angle. Now, if it's true for sides A and B, then it's not so much of a stretch of the imagination to imagine the triangle just rearranged slightly differently, and it would be true for C as well. So we get our important final result, and this is the way this formula is written on your data sheet, that A divided by sine A equals b divided by sine b, which equals c over sine c. And this result here is what is called the sine rule. Now that we have seen an example and looked at the generalized formula, in the next video we're going to run through a couple of examples of how we might use this formula.